Hi everyone, I'm Gillian McCann and welcome to my presentation today where we're going to explore the evolution of conversational AI. For years I've heard the promise of chatbots and self-service. To be honest, often the reality hasn't quite lived up to the hype. Today we're going to explore how some cutting-edge technologies like large language models, retrieval augmented generation, RAG, and agentic AI are changing the game and helping to move us forward beyond basic chatbots to truly intelligent and helpful conversations. And just a quick bit about me. I'm an AWS machine learning hero and formerly CTO of Workgrid Software, which is a company that specializes in AI-driven employee experience. And my professional focus in recent years has been on leveraging cloud and artificial intelligence in both enterprise and startup companies to help develop products that are fundamentally human-centric. I aim today to provide some insights into building enterprise-level conversational AI and share some of my experience and industry insights. I think it is important to have high level understanding of this game changing technology so you can see beyond the hype and plan how to implement within your organization. So, what is conversational AI? Well, simply put, it's technology that enables a computer to understand natural language and simulate responses back to human speech and text. Think about text based chatbots or voice assistants or virtual agents. The goal really is to interact with technology in a natural and intuitive way, just like talking to another person. Easy, right? Well, without going into any depth of detail, really, here's a diagram that kind of illustrates where conversational AI fits within that broader AI landscape. And this covers a range of fields. Conversational AI draws upon core AI branches such as natural language processing, natural language understanding for understanding user intent, natural language generation that generates responses back, and automatic speech recognition and text to speech for voice interfaces. But as you can see, not all AI is conversational AI, and not all conversational AI is just AI. It draws upon linguistics, heuristics, and language rules, and it takes a blend of different disciplines to create truly conversational experiences. So, why is conversational AI relevant for self service and IT and the employee experience? Well, the vision has always been clear. 24/7 access to instant answers, regardless of time or location, which empowers employees and customers to resolve issues quickly and independently. It frees up valuable IT and support teams to focus on more strategic initiatives. A world where technology proactively anticipates our needs and effortlessly guides us to solutions. Magical, right? And when self service conversational AI is well designed and tested, it can be fantastic. No one really wants to phone the help desk if they can get away with it. But let's be honest. The current reality of basic automated self service often doesn't fully deliver on this potential, and many organisations are probably familiar with some of the limitations. Common challenges that I've heard and seen include user frustration with a poor experience, they get answers that are incomplete or irrelevant, and there is a perception of lack of true intelligence, like it doesn't do X, Y, or Z. And they're difficult to maintain, and there is a poorly understood development process. There's quite limited original natural language understanding, and this arises then potential questions on the return of investment. To understand some of these limitations and then how conversational AI has evolved, I thought it'd be useful to walk through what I consider what we're calling now traditional chatbot components and flow. And in this diagram, you can see that the core AI component is the NLU engine. And this engine, whether it's a cloud service or custom models or part of a platform that you've purchased, really has twofold objectives. Firstly, to recognize the user's intent. What is the high level goal? And secondly, entity extraction. How to identify specific information that is needed to fulfill the intent. And for example, if user types reset my password, please, the engine needs to understand the intent is password reset and extract the necessary entities, in this case, at least the user's identity and potentially the system they're referring to. And this required information is gathered in different ways. The bot might ask clarifying questions to extract more information through dialogue management, or the system might implicitly understand who that person is by injecting context like user identity from their login. But there is complexity. Firstly, what I consider the NLU training burden. For these engines to work, they really supervise machine learning models under the covers, and that means per intent or per conversation, you need to provide training data. So, as the desired scope of the chatbot expands, this training process can become increasingly complex and resource intensive. And it often results in what we call bot bloat, as in more and more intents are added to the one bot to meet the user demands or the different domains. The bots become overly large and unwieldy, making them quite difficult to manage, update, and maintain. And then this led to different patterns where we had smaller domain bots, and the complexity just moves to a different area where we have to orchestrate across different bots, which we call bot orchestration. And also, they're quite limited in their scope and quite rigid. They're designed for very structured conversational paths and flows, and they do struggle significantly when the users deviate from those paths or ask unexpected questions. And the idea of AI generating free-form text, as LLM do today in the responses, was often viewed with concern. So the focus was on scripted responses and structured paths, and this was driven by a desire for control and predictability. But this reduces the naturalness and flexibility of the interactions. And this emphasis on structured paths and scripted responses meant that conversation design and user interface experience is really critical, but it can also be quite constrained. It is essential to design a UI that guides users down predefined paths and to ensure users quickly understand what the bot could and could not do. The flexibility and natural language fluidity was often sacrificed in favour of this control and predictability. And another area which is not really talked about but often underestimated is, as I say, the maintenance need and the constant iteration. Tendency to view chatbot development as like a one-off project. However, in reality, a significant ongoing maintenance essential for long-term success. And this constant iteration is really based on conversational analytics and user feedback and how users are interacting with the chatbot. It's a data-driven technology, and the feedback loops are really critical for continuous evolution and long-term effectiveness of any conversational system. So as we look towards large language models, many areas have evolved, but also it is important to understand that some areas of complexity will remain because it is important to understand that AI is only one component in building these AI products. Okay, so hopefully it's clear why there may have been problems with the traditional approach, but how does a generative large language model help? Before we dig into that, I want to do a super high level overview of how they work. And it might seem complex, but the core idea is surprisingly straightforward. Prediction. In essence, they're constantly predicting the next word based on probabilities and decoding strategies, and the words that are being considered come from the model's training data. The selected word becomes part of the input for the next prediction. So the LLM generates text word by word. And this is why they're called non-deterministic. It means that there's a probability element involved. So even with the same input, a large language model might generate slightly different outputs each time. But large language models are more than just improved text generation tools. They represent the fundamental shift in natural language capabilities. And for me, the most remarkable aspect of the LLMs is their ability to perform a wide range of machine learning tasks simply by using a prompt or a set of instructions. A single LLM with effective prompting can perform a wide range of tasks that previously would have required separate specialized models. So tasks like name density recognition or sentiment analysis or translation or summarization or text classification, in addition to the natural language understanding and natural language generation we talked about before, these all become possible with a single LLM simply by adjusting the prompt. And this versatility stems from the vast and diverse data sets that are used to train the models. And they learn the patterns across this data, allowing them then to generalize and perform these tasks with a remarkable adaptability. In essence, effective prompting can really unlock a lot of potential and flexibility. As you can see in the new flow, there is much more reliance on AI in the form of an LLM for managing the conversations and understanding the intent and extracting information, and generally providing a more fluid natural language flow. But as I've learned with tech over the years, the complexity just moves somewhere else. So now rather than having to add conversations, we actually need to add guardrails to stop conversations taking place about certain subjects. And now we consider the limitations of general large language models. These are trained in broad internet data. So for example, general knowledge, like such as who's won the Battle of Hastings, it performs well, provides a sourced answer, as you can see on the left. But when you ask organization specific queries like what's the number for the help desk, obviously it will not know that. It hasn't been inherently trained on your internal details, phone numbers or policies or proprietary data. So therefore, for enterprise self-service to truly effective, we need to ground the AI in your own knowledge. So how do we bring your data or information to a model? Well, the vast majority of products are leveraging one or more of the techniques outlined below to bring that external knowledge to the model. AI models are just one piece of an overall AI product. Yes, powerful AI capabilities are contained within those models, but to make it useful, we need to bridge the gap between the AI magic and simple system integration. And today we're going to focus on two aspects of that, RAG and Agentic AI. Retrieval augmented generation, or RAG for short, has evolved for the purposes of supplementing the model with your own data using in-context learning. And this just means that information not existing in the model training has been provided with the context of the prompt. And importantly, the model isn't trained any further and does not learn anything from the information you provide. I mean, its most basic, RAG is broken down into three areas. Ingestion, your data sources or documents are chunked into a small size and converted into vectors with an embedding model and stored. And then in real time, a user query is also embedded, and that is used to match or retrieve from the stored content. Those retrieved chunks of information are then passed to a large language model for generation or synthesization of an answer. Looking at the diagram, hopefully it's very obvious that most of the work is in the boxes that enable the retrieval of the relevant content. So really, RAG is all about retrieval. So in essence, it's all about search. And in my experience, building conversational AI and search systems, good search can be hard to get right. And why is that? So search itself is a balance between precision and recall. Precision refers to the proportion of retrieved documents that are relevant. The aim is to minimize irrelevant results and maximize the retrieval of truly useful information. Recall, on the other hand, is a proportion of all relevant documents that are actually retrieved, and the objective of search is to ensure that enough information is surfaced, avoiding the omission of key content. And the challenge really is of finding the optimal balance between these two metrics. Overemphasis on precision leads to low recall, and you may miss crucial information. Conversely, prioritizing recall means you get a long tail of results, and precision and can overwhelm the users with irrelevant results. So goal really is about getting that balance right for your use case. Semantic search helps get that balance correct and is a key component for effective RAG, and it moves us beyond simple keyword matching to understand the underlying intent of a query and the contextual meaning of words. So instead of keywords, semantic search uses something called embeddings, which is a semantic representation of text. In essence, words become numbers, which are known as vectors, and it uses these when it does the search compared to using the words. So it means queries like gym opening time question mark retrieves results like workout hours, gym times, opening hours of gym, all semantically related, but they do use different keywords. Semantic search is not new, but in recent years, with these large models and more importantly, pay as you go APIs, along with the RAG pattern, it has been a supercharged area of interest and research. On one side note is the choice of embedding model does actually matter. I mean, if it's trained on general purpose internet data and you're trying to use it to find relationships on very niche specific domain language, it may not always work. And that's why maybe when considering RAG, we don't want to always throw the baby out with the bathwater. Well, what do I mean by that? Well, semantic search requires the need to store and search vectors, and there's been an emergence of a whole range of really cool products that do that. But what about the search engines? I thought this was a good representation of what a search engine offers you may need to consider when you're making your implementation choices. And there's some areas in red that I want to call out of particular interest. Out of the box ingestion tools and permission models. When data is ingested from, say, a SharePoint site, it needs to include the content and any permissions that need to be applied. And it also needs to be kept up to date and re-ingested as changes occur. And when a user asks a query, their permissions need to be applied so that secure content is not surfaced. I think this is often an overlooked area in complexity and is a massive issue if you get it wrong. In addition to semantic search engines usually offer a wide range of search techniques. Hybrid search, which is the ability to use both text and semantic search, and it is a powerful retrieval technique. And it's also not just text or semantic search. You can have date, time, numeric, or location based questions. And search engines offer a whole range of capabilities that allow that. Because consider this, it's not just finding the needle in the haystack, or as I like to semantically say, finding a sharp sewing device in the haystack. You really need to understand the types of questions and queries that the users are expecting to be answered. It may be beyond the simple factoid questions like count the number of needles in the haystack. You may need to handle analytical questions, interpretive questions, or even anomaly detection type queries. Effective search requires handling a wide range of queries, and it's key to understand the complexity of what your users need. And we also think we need to understand the amount of information that's going to be available, because when we think in this analogy, adding more information and more documents is not about adding more intelligence, it's actually about adding more hay. And if we think about how to deliver holistic employee experience across a range of domains, we need to consider really how to leverage enterprise search. But honestly, who hasn't complained about not being able to find anything at work? But something to consider is that maybe the problem with enterprise search is the enterprise. Now, that's a bit bold and dramatic, but just a way of saying that maybe it's not always a tech problem and cannot always be solved by tech. I mean, who ensures the quality of the content, the relevance and freshness of information, or ensures that the data or documents are classified and permissioned correctly? All these need to be considered because, as we know, garbage in, garbage out. Search is a data driven technology, so ensuring that it's not just turned on and left without tuning, without incorporating user feedback is a mistake. And setting expectations on this is important because the more we talk about RAG, really we're talking about AI search. And the one thing that I like to say in all my talks is AI is not magic. Changing to an LLM model and RAG is not going to solve these issues. And just to show it's not just me that thinks this, I asked a friendly model, why does RAG fail? And here's some of the points. Poor knowledge-based quality, garbage in, garbage out, just like I said, ineffective retrieval, limited context passed to the large language model, which again is ineffective retrieval, the ability of the model to not use the context effectively, potentially hallucinations, and then also that really important security and access control. The user has more access to information than they really need. So ultimately with this diagram, what I'm trying to show is that there is more to it than the basic RAG. There's a lot more techniques and search capabilities that need to be considered. The LLM piece of this is really the easy part. So in my head, this is what a production level RAG based product actually looks like. There's lots of knobs and lots of configurations and lots of tuning to be able to get it to consistent quality answers. So we did a very quick tour of RAG, and this is very much a pattern that's being discussed in 2023 and 2024, but also new patterns have started to emerge, namely agentic AI and more recently reasoning. In early 2024, Andrew Ng, founder of Deep Learning AI and a leading figure in the AI industry, said the following: I think AI agentic workflows will drive massive AI progress this year, perhaps even more than the next generation of foundation models. Well, this trend has only accelerated in 2025, and agentic AI is being marketed extensively across a whole range of products. So, what is it? Well, there actually is a bit of debate or distinction around things like agentic AI, agentic workflows, AI agents, but in essence, they're a software or a system that leverages an LLM for some component of decision making in a workflow. Anthropic AI has distinguished between agentic workflows and more autonomous AI agents, whereas Hugging Face defined it as a LLM based system with varying levels of agency. I think what is interesting is when we look at the guidance from Anthropic, they kind of say keep it as simple as possible. And that may mean not building agentic systems at all. Agentic systems often trade latency and cost for better task performance, and maybe you should consider this trade off when it makes sense. When more complexity is warranted, workflows offer more predictability and consistency for well defined tasks, whereas agents are the better option when flexibility and model driven decision making are needed at scale. Anthropic also say for many applications based on their review of their customers' use cases, optimizing single LLM calls with retrieval or RAG and in context examples is usually enough. In a way, doesn't matter what you call them. Don't get caught up in the buzzword bingo and the hype. Chatbot, Copilot AI agent, agentic AI. Focus on the outcome and your use case and not the technology. Ultimately, they're all kind of conversational interfaces that provide information and perform tasks on behalf of your user. So what are the core components of agentic AI? In reality, they're really quite simple. It's about the information that you provide to a large language model within the prompt itself. First of all, there's context, and it's usually like short or long-term memory is provided, the current conversation or previous conversation. Some form of identity, like a user profile or job role, and also a persona of the agent is usually provided. Is it a sales agent? Is it customer service, etc.? And as part of that, we have planning, and planning is really different types of prompts, of which are constantly evolving, of how to get the best how to provide instructions really to the large language model or the agent of how to proceed. But most important in my mind is tool or function calling. I mean, as I've said, a key concept within agentic AI is tool or function calling. And this really involves defining a specific set of tools, such in this example, reset my enterprise password or create IT help desk, with clear documentation and parameter specifications. It is really, really important that when you're defining tools that you use the most descriptive language possible. Words are really the new programming language here. So subsequently, the large language model, guided by the context and memory they've provided and the explicit instructions and the type of prompt, can decide which of these tools it should invoke. For example, query like my laptop screen is broken, it can decide to use the create the IT help desk tool. It has automatically categorized this issue and initiates a ticket within your ITSM. And when you think about it, when you think back to old school chatbot that I showed, I mean, these seem quite similar to building out intents and classification models with entity extraction. But from my experience building them, they're much more flexible and dynamic, and it makes them much easier to build. But each step that the model takes needs to be carefully observed and monitored. And this is just a quick example. I used like a Gemini model here. I quickly defined a couple of ITSM type tasks and injected them in as tools into a model. And as you can see, it very quickly can create natural language conversations around this topic. Now, the one thing to note, AI is not magic. It's not actually connected to a system. We actually have to write that code. Okay, we've done a bit of a whirlwind tour, some concept, talked about how tech works and the impact that it may have. But how do we get to real users in production and how do we actually see the value? To progress from a POC to a production deployment, you really do need a structured and iterative approach. I mean, it starts with discovery. You got to have an understanding of your use cases. You understand your queries and your data and your user needs. And I think having an understanding, think big, have a holistic plan, but obviously you're going to have to need to start quite small and experiment. So you can have those discussions about how much you need to build, what you could buy. What integrations you need to define. And I think upfront, trying to think through objective success criteria is really helpful. And what you're trying to get in place here is a very fast iteration cycle. Um, and how do you do that? How do you get confidence? I mean, vibes are not enough. When is it good enough? And I think evaluation is not talked about enough, but is such a massive piece of any AI product that you may buy or build. And ultimately, deployment. And when we say deployment, this is not something running in a Jupyter notebook that you're showing to your stakeholders. This is a deployed environment. And in the deployed environment, whether that's a dev, a test, or a production, it's about having real users, whether it's a small group of employees or stakeholders, actually using the thing for the purpose that you have built it for, establishing feedback loops and really having observability. You need to think how to do that with privacy, and you need to iterate on the analytics and the feedback for continuous improvement. So let's talk quickly about discovery. Discovery is all about information gathering to help you make the best technical choices and determine the best use of the AI. If you have an existing product capability, what can be learned from the existing usage patterns or problems that you see? What are the limitations? What are you trying to solve for? Importantly, what's the expected benefit? Are you trying to save X number of hours a week? Are you trying to provide a better employee experience? Are you trying to generate better reports or manage customer service faster? What are your key metrics that you're going to measure success against? What is the risk appetite of a generated answer being very useful but not being precise? The non-deterministic nature of this technology will mean that it will not be 100% same answer all the time. And how much control or how much agency do you want to give the AI? Where do you think a human in the loop is beneficial or is ultimately required? And I think managing expectations is key. Everyone has access to ChatGPT, Claude, ton of AI tools, so expectations are very high. But the reality within an enterprise ecosystem, I mean, POCs are easy, demos are easy, and getting people excited about technology can be easy. But what you need is that deployed environment with the built-in feedback, evals, and monitoring so you can iterate very, very quickly. And we say discover the data. Where does your answers and your information come from? What systems do you need to be connected to? Do you have access to that? Are APIs available? This is not about the AI. This is about where you're getting your data from. And you think about RAG. I mean, is it War and Peace or is it engineering manuals about parts that you're trying to use semantic search on? Is it scanned documents or is it Word? Is it a common topic like HR? Is it very specific equipment specification? Is it 200 documents or 200 million? Is it words or pictures, tables, code, or is it a mix of all these things? I think importantly, does the data have the permission model that you need to replicate it? All these questions kind of need to be discovered. Well, actually, all the answers to these questions need to be discovered. And the more information you can gather up front, have that holistic view of what you're trying to build will really help you narrow down your choices. Discover your users and their queries. Words matter, and in some ways, English is both the simplest and yet the hardest programming language to build with. So, like questions like when are we paid are very different from compare and contrast XYZ from 2023 to 2024, or summarize ABC about the company work from home policy, or create an action plan based on company three objectives. So, understand your query types, the questions versus instructions will help and determine how to retrieve correct information. And you need to think carefully about the user experience. What UI components really would be beneficial? Where should information be surfaced as forms or suggestions or clickable buttons versus always being a conversation? Should the system know or should the user know like which agent to ask? So conversational user experience is still very important. I think it's important to set expectations of what it can and importantly can't do. There is so much hype around AI and LLM at the moment. I think being understanding the technology and being realistic at what can be achieved will only be beneficial in the long run. Evaluation is critical to your success, and you need to think carefully about what is important and indeed your appetite for not being perfect. There's new models, new prompts, new techniques. You can add new documents, you can add new tools, you can add new agents to your ecosystem. So, how do you test that? I mean, here's a real example. We used a new and improved model, and we actually saw our parameter hallucination in our agent tools increase from 20% to 50%. Basically, the new improved model made it basically unusable. So how do we know that? We knew that because we built evaluations on our use cases. So what type of vals do you need to build confidence? Well, it really depends. It depends on your use case and it depends on the techniques that you're using. So you need to work out what metrics are most important for you to track and what data you're going to use. So there is a range of data sets available. A great power of large language models is actually to generate synthetic questions, synthetic answers, synthetic conversations for you to really test what potentially the system can do. But also it's important to use human curated or existing logs that essentially you can look at to see if there's a baseline of types of queries or conversations that your users have had in the past. And RAG and agent evaluation is a constantly evolving area, and there's lots of new products and papers coming out all the time. But I have listed some of the sort of main evaluation metrics that exist today. We're really looking at things, for example, within a RAG, like the faithfulness of the answer or the relevance of the answer. And to do that, you have to create data sets that you can compare and contrast your gold standard answer to with what has been coming out of your chatbot. And it's very important to do evaluation and testing as early as possible and consistently through the different cycles. So from my experience, we've done evals and testing in the experimentation phases, in the development phases, in the deployed environment, and ultimately evaluation and testing in real time in production. So I said this before, it's not a POC if it's just running in a Jupyter notebook on a dev's machine. I say that having done that myself. And it's not really a POC if someone has uploaded 10 documents into a new product. It needs to be something defined of relative scale in relation to what you're trying to do. And then ultimately, you got to get it in the hands of users. It has to be a deployed environment in my mind. So it could be a small number of employees, stakeholders, a small number of customers, but ultimately getting it out there so that you can then iterate as quickly as possible once you get that loop going. As I said, you can change the prompts, you can change the models. All these things have constant impact, and you need to have a consistent way to validate and improve on the system. And just to bring it right back, as I say, it's not a once and done technology. It's a data driven technology. You'll be surprised what people ask in production. So you got to keep iterating, and you got to keep this loop as tight as possible so you can move as fast as possible. So it's an iterative cycle, and one size does not fit all. Everything is dependent on your use case. So come to the end of this whirlwind tour of LLMs, RAG agents, and conversational AI, and hopefully you've learned something and you've got some key takeaways. I mean, ultimately, conversational AI is complex, but it is a very rewarding technology and can deliver really engaging experiences. LLMs are not a silver bullet. AI products need much more than a good model. RAG is really about having really good search. One size does not fit all, and really keep it as simple as you can. Understand the technology beyond the hype. POCs are easy, and don't underestimate the complexity and maintenance that you may need. Thanks for listening. I hope this was helpful. Bye.